So we left off yesterday. We were talking about finding the missing parts of oblique triangles. And we said that of those 6 parts of a triangle, of the 3 sides and the 3 angles, we were going to be looking at knowing any combination of 3 of them and being able to find the other 3. And of course, there are 4 possible combinations. We could have the case where we know 3 angles and no sides. This is the one case that we cannot find the other pieces. We can't solve that triangle. Knowing all 3 angles, we can make a similar triangle, but we can't necessarily make the exact same triangle. If we know 2 angles and 1 side, we can always use the law of sines, as we've been working on. And that, of course, is just length of side A over the sine of angle A equals length of side B over the sine of angle B equals the length of side C over the sine of angle C. They're all the same ratio within the triangle. Some textbooks, remember, have that the other way around, the sine over the top of the length of the side, but it's the same ratio either way. The third case was having 1 angle and 2 sides, and this one gave us actually several subcases. We could have the side opposite the angle is the larger of the sides. In that case, we're good to go with law of sines. We had the side opposite the angle. Is the smaller of the 2 sides. And we needed to know if the angle is acute or obtuse. Because if it's obtuse, then remember, once we solve it, we do the inverse sine, we have to take the supplement of that angle, subtract that angle from 180 degrees to get the correct angle. And we will do an example of that before we move on to the next concept today. Of course, there is a very, very uncommon case here. It is a slight possibility when that side that's opposite the angle is too small that it doesn't actually form a triangle. And this would occur, we would know this was occurring because the sine of the angle ends up being larger than 1. So when we do an inverse sine, we get an error. In that case, we know that what's happening is that side that's opposite the angle is so small it doesn't even reach back to the other side. And then there is a third subcase where we have 1 angle and 2 sides. And this is where the angle is included. In other words, the angle is between the 2 sides. And here we did not have a side and the opposite angle. So in this case, we're going to use what we're going to look at mostly today, law of cosines. And of course, there is a fourth case that we have not looked at all yet, and this is where we know all 3 sides. And in this case, we're also going to be using that law of cosines. So before we get to that law of cosines, let's take a look at most complex example of the law of sines, where we have two sides and an angle that's opposite the shorter of the two sides. So here I'm going to tell you that we have angle B, which is 38 degrees. Side B is 23 inches. And side C, we're going to call this 45 inches. And I am going to tell you here that, excuse me, angle C is obtuse. Actually, I'm going to make sure this works out. I'm going to make angle or side C here. We're going to make it 37 inches just so that we don't end up, I don't want to end up with that case where the side is not long enough to reach back to the other side. We can sketch this out and look something like this. Here is going to be angle B, angle C, angle A. So little a, little b, little c. C here is going to be 37 inches. B is going to be 23 inches. Angle B is 38 degrees. So to find angle C, we have the side and its opposite angle. So we'll start with that. 23 inches over the sine of that opposite angle, which is 38 degrees. This is going to equal, well, we have the 37-inch side. That's the only other piece of information we have. It's going to be over the sine of angle C. So once again, when we're looking for the missing angle, there's going to be an extra step on our law of sines calculation here. We will start out by cross multiplying and dividing. I'm going to make sure my modes are correct here. It's at 2 degrees and not radians. We're going to have sine of 38 degrees times 37 divided by 23. We get 0.9904. That is the sine of angle C. As we've seen the last couple of examples yesterday, we then have to do the inverse sine, 0.9904, to get one of the potential angles for C. It's not necessarily angle C, it's one of the two potential angles that it could be. So second sine, second answer. Again, I use that answer key so that I don't get a round off error by writing it down and typing it back in. Gives me 82.06 degrees. Now, I'd said this is one of the possible angles for C. The reason I say that is we were given the information that C is obtuse. So 82 is not obtuse. So angle C would be the obtuse possibility. The calculator always gives us that acute possibility. To find the obtuse angle, we have to find its supplement. In other words, we subtract it from 180 degrees. This is 97.94 degrees. Angle C is 97.94 degrees. Which means we can find angle A by doing 180 degrees and subtracting the 97.94 and the 38 degrees that we have for those other two angles, which is going to give us, what, 44.06, I believe, degrees. Now we have one of the sides and one of the angles, or actually both of the angles now that we're missing. All that's left is find side A, and this is just now a pure law of sines problem. We have our 23 over the sine of 38 again, equals little a over the sine of that opposite angle is the 44.06 degrees that we found. And we'll cross multiply and divide. So we'll have 23 times the sine of 44.06 degrees, close that parentheses, divided by the sine of 38 degrees. 25.98 is again. So put that in up here, 25.98. Now, if you recall, there are two things we should check. First is to make sure longest side is opposite the largest angle, shortest side is opposite the shortest angle. Well, 37 is the longest side, 97.94 is definitely the largest angle. 23 is the shortest side, 38 is definitely the longest angle. So that's the first check we should perform, is to make sure that matches up. The second check is to make sure the two shortest sides add up to be larger than the longest side. And here, 25.98 and 23 add up to be 49.98, or sorry, 48.98. That is longer than 37, so that works out as well. Again, those little double checks don't guarantee that we have the right answer. They just stop us from making really major mistakes. So we had mentioned the possibility where we had one angle and two sides where the angle was included between the two sides. So here let's say side A is 47 millimeters, side B is 59 millimeters. We have angle C of 61 degrees that is included between them. We cannot do law of sines here because there is no combination of side and opposite angle. Or angle and opposite side, if you want to look at it that way. There is no combination where we have that. So we're going to use the law of cosines. Now, the law of cosines is set up, it is specific to the angle that we have and the side that is missing. The law of cosines allows us to find that one missing side. And once we have that missing side, then we can go back to using law of sines for the rest of the problem. So the formula allows us to find side C is actually C squared is equal to A squared plus B squared. Now that should be looking familiar at this point. That's just our Pythagorean theorem for right triangles. Our law of cosines is actually often referred to as the generalized Pythagorean theorem, because it starts off like that. C squared equals A squared plus B squared. Then there's an adjustment factor here to adjust for the fact that angle C is not a right angle. That adjustment is minus 2 times A times B times the cosine of angle C. Let's look at how that would apply here. So C squared is equal to A is 47, so that'll be 47 squared, plus B is 59, so that's 59 squared, minus 2 times 47 times 59 times the cosine of angle C is going to be 61 degrees. A little bit of a tip here. This piece over here should be put in your calculator, and it should be put in all as one piece. The reason I say put it in all as one piece or all as one big long formula is if you hit the equals key at the wrong point, it totally messes up this calculation. There are only two spots in that calculation where you can hit the equals key and not screw it up. So we're going to put it in all at once. So 47 squared plus 59 squared minus 2 times 47 times 59 times the cosine of 61 degrees. 3001.24. Remember that c squared equals 3001.24. So to find c, we still have to square root. I'm going to keep that in my calculator again so I don't have to type it, write it down and type it back in, round it off. So second square root, second answer, 54.78. Those other measurements are in millimeters, so that is also millimeters. This is 54.78 millimeters. Handy calculation, to be honest. And like I said, put this whole portion in your calculator all at once. And do not hit equals or enter until you've completely entered that whole section. Now we have a side and its opposite angle, so we can proceed to continue solving this using the law of sines. You should never have to apply law of cosines more than once to the same triangle. So we have 54.78 millimeters over the sine of 61 degrees. This will equal the 47 millimeters over the sine of angle A. Now you might ask, well, could I have chosen the 59 millimeters? The answer is, yeah, I could have, but I don't want to. And there's a very good reason why I don't want to. So now that I have this side and its opposite angle, that's what I put right here for my law of sines. I want to use, of the other two sides, I want to use the smaller one, which is the 47, to find its opposite angle. And there's a reason for that. Because I know that in a triangle, there can only be one obtuse angle. So I know that 47 is going to be smaller. 47 is the smaller side, so I know that angle A has to be acute. The only angle that could be obtuse here is angle B because it's opposite the largest side. And I'm not saying that B is obtuse. I'm saying we don't know if it is or not. I purposely drew this so angle B is really close to a right angle. So it could be like 85, could be 95. We don't know for sure. So rather than take that risk and guess at what B is, we're going to find the smaller angle that we know has to be acute. So in this case, that's angle A because it's opposite the smaller side. We're going to find that first, and then we'll find B by just subtracting from 180. So we don't have to worry about when we do an inverse sine if we're finding the acute or the obtuse angle. So here it's going to be cross multiply and divide. So sine of 61 degrees, close that parentheses, times 47 divided by 54.78. We get 0.7504. That is the sine of angle A. So we do the inverse sine of that answer. Get the angle A is 48.63 degrees. Angle A, 48.63 degrees. Now I can find angle B and be assured that I have the right answer, whether it's acute or obtuse, by simply doing 180 minus 48.63 minus 61. And what does that give me? 109, so 70.37 degrees. B is acute, but again, we wouldn't have been totally sure of that had we, done an inverse sine on it. Now, I mentioned that this law of cosines, the formula is set up angle specific, or side specific, however you want to look at it. What do I mean by that? Well, the formula is set up so that our missing side is side C. If side C is not the missing side, Let's say I tell you that angle A here is 58 degrees. And side C over here is 29 millimeters. Side B down here is 41 millimeters. I want to solve this. Well, A is the angle included between those two given sides, so this would be law of cosines. Again, that's C squared equals A squared plus B squared minus 2AB cosine C. Well, here we have angle A instead of angle C. So what I want to do is in my formula, I want to trade the A and the C. So instead of C squared, this will be A squared. Instead of A squared, it'll be C squared. Plus B squared minus, instead of 2AB, it's going to be 2CB. And instead of the cosine of angle C, it'll be the cosine of angle A. So again, that was because instead of having angle C, I had angle A. So, and instead of looking for side C, I'm looking for side A. So everywhere in my formula that I saw a C, I traded it for an A, and everywhere I saw an A, I traded it for a C. And now it's just the same thing. A squared equals C squared is 29 squared plus B is 41 squared minus 2 times 29 times 41 times the cosine of angle A is 58 degrees. Once again, I want to do this whole side all at once in my calculator. 29 squared plus 41 squared minus 2 times 29 times 41 times the cosine of 58 degrees. Gives me 1261.85. And again, I'm leaving it in my calculator. I'm not clearing out my calculator. I take the square root to get A. Second square root, second answer. At 35.52. That is in millimeters. Well, the key there was to just adjust my formula, trading the letters where appropriate to get the formula that is correct for the situation that I'm doing. Now, have a side in the opposite angle here. I can use law of sines, but remember I want to use the smaller of the other sides. So I have my 35.52 over the sine of 58 degrees equals, I'm going to use the 29, and that's opposite angle C, so that'd be over sine C. So when I cross multiply and divide here, it'll be the sine of 58 times 29 divided by 35.52. 6924. And do an inverse. Second sine, second answer. At 43.82 degrees. C is 43.82 degrees. So B is going to be 180 minus that 43.82 minus 58 comes out to be 78.18 degrees. Now again, B came out to be an acute angle, but we would not have known that for sure if we'd have looked for B, if we'd used the 41 first, the 41 millimeter side first. Could be 78.18 or 18. It could have been 101.82 degrees. We weren't sure because it's close to 90 degrees. So as we've mentioned, it's always safer to look for that smaller angle, using the smaller side first once we have this third side and use our law of sines. one last application of this law of cosines. It's really handy. And that was that fourth case that we had where we knew all three sides. So in this case, I know that side C is 27 millimeters. Side A is 35 millimeters. And side B is 32 millimeters. I can find one of my missing angles. And it really doesn't matter which one I find first. But law of cosines is set up to make it easier to find angle C. So remember, law of cosines is C squared equals A squared plus B squared minus 2 AB cosine C. Well, here we know side C, we know side A and B. What we don't know is angle C. So if we solved this for the cosine of angle C, so I can subtract A squared and B squared from both sides. That would give me C squared minus A squared minus B squared equals a negative 2AB cosine C. And then I can divide both sides by a negative 2AB. Well, that's just going to give us C squared minus A squared minus B squared over negative 2AB equals the cosine of angle C. That right there is what we want. So what we can do now is we can put in our sides. Side C is 27, so it's 27 squared, minus side A of 35, so it's 35 squared, minus B of 32, that's 32 squared, over negative 2 times A of 35 times B of 32 equals the cosine of angle C. When we do this calculation, we're going to do everything on top first. So let's do that. 27 squared minus 35 squared minus 32 squared. This is going to give us a negative number, and that is just fine. Negative 1520 is our result on top. Now we want to do the bottom. That's going to be a negative 2. Make sure we enter the negative, use the negative key, not the minus key. Times 35 times 32, giving us a negative 2240. That equals the cosine of angle C. So C is just going to be the inverse cosine of negative 1520 divided by negative 2240. Now, a negative divided by a negative is a positive, so I could leave out the negatives if I wanted to, but there will be times where one of those numbers is positive, so we have to make sure we keep the signs straight. So inverse cosine negative 1520 divided by negative 2240. Close that parentheses. We get C is 47.27 degrees. So C here, 47.27 degrees. That makes sense. C is the shortest side. Angle C, that's a relatively small angle. Now we would go about finding the other angles using the law of sines, because we now have a side and its opposite angle. But just like we did in the last couple of examples, we would want to look for angle B first here, because angle B is across from the smaller of the other two sides. So we know that B has to be acute. We're not saying that A is obtuse. We're just saying A is the only angle that could possibly be obtuse, because it is across from the longest side in that triangle. Do one more example of finding that missing angle, and then we'll give you your homework and get on with the day. Of course, I'm going to put a situation up. Well, it doesn't really matter. We'd pick the one nice thing about finding the missing angle when we have all three sides is you can really pick which angle you want to look for, so you don't ever have to worry about rearranging the formula. Let's say that this is 3.2 inches. This is 4.3 inches, and this down here is, we'll go 4.6 inches. Once again, I'm just going to pick to find angle C over here. And we have that formula already rearranged for this. C squared minus A squared minus B squared over negative 2 times A times B equals the cosine of angle C. That's just our law of sines rearranged, solve for the cosine. So we got C is 3.2, that'll be squared, minus A of 4.3, that'll be squared, minus B of 4.6, that will also be squared, over a negative 2 times A of 4.3 times B of 4.6 equals cosine of C. Again, I'm going to do everything on top first. 3.2 squared minus 4.3 squared minus 4.6 squared. Negative 29.41. I'm going to do everything on bottom. Negative 2 times 4.3 times 4.6. Give us a negative 39.56. Equals the cosine of C. So to find C, it's going to be an inverse cosine of the negative 29.41 divided by the negative 39.56. Equals angle C. The second cosine, negative 29.41 divided by negative 39.56. 41.98 degrees. C is 41.98 degrees. And of course, now we'll find the other angles. We would find angle A first. We use the 3.2 over the sine of the 41.98. And we angle A would be 4.3 over the sine of A. We would be finding A first because it is across from the smaller of the other two sides. Any questions? For homework here, going to be in that packet still. Page 382 through 385. 18 through 42. Technically, it's actually 19 through 41, the odds. It's just a continuation of that same assignment we started yesterday with our law of sines. Now we're going to be looking at applying law of cosines and some, just trying to determine when do we use the cosines and when to use law of sines. Tomorrow there will be a quiz, so for those of you that want to work ahead, the quiz should be posted out there already for you. So you can do that quiz if you'd like. Tomorrow we'll wrap up all this trig stuff. If we have time, we'll look at something called the law of tangents. And then Thursday, of course, remember, is our unit test. So with that, I'll let you guys have the last 15 minutes here to get started on homework if you prefer. I'll be on here to answer questions.